the body in radii during the time t. Also, phi is equal to 2 pi f, where f is the frequency. It will be noted that the time capital T to describe the circle once, known as the period of motion, is given by capital T is equals to 2 pi over radians. Since 2 pi radians is the angle in one revolution, distance s over t is the speed. V of rotating object and theta over t is the angular velocity. V is equals to radians times phi, where r is the radius of the circle. Example 1. A body traveled round a circle 12 times in 18 seconds. If its speed is 3 meters per second, calculate its angular velocity, the radius of the circle. The time to go round the circle once is equals to 18 over 12 seconds. Solution. 180 degree is equals to pi degree, pi in radians. 360 degrees is equals to 2 pi. Angular speed is equals to phi is equals to 2 pi over period t. We know that our period is 18 over 12. Then putting in and substituting the value of pi, we now have 12 times 2 pi all over 18. We now get our angular speed as 4.2 radians per second. Velocity we are asked to find is equals to radius times phi, which is the angular velocity. Where v is the linear velocity, r is the radius of the circle, w is the angular velocity, we now see that r is equals to, making r the subject of the formula, we now have our r equals to v over velocity, linear velocity over angular velocity, which is 3 over 4.2, which will now give us a radius of 0.17 meters. The radius of the circle is now going to be 0.17 meters. Circular motion. Circular is the locus of a point that moves in such a way that they are equidistant from the center. Any object swing circular motion have two directions in the center. Angular velocity is equals to theta over t. Phi is equals to theta over t, where t is equals to time. Theta is also, making theta the subject of the formula, we also have phi times t, where theta is the total angle covered. Theta is also equals to the radians in radians seconds. Pi radians is equals to 180 degrees. 2 pi radians is equals to 360 degrees. Period capital T is equals to 2 pi over angular velocity, which is phi, where capital T is the period for one complete oscillation. Arc is equals to theta over 360 times 2 pi r. Arc is also equals to radius times theta. S, the distance, is equals to radius times theta. Dividing both sides by t, we have that st over is equals to radius times theta all over t. We now discover that s, distance over time, is the velocity, is equal to reduce theta over t is the angular velocity, which is phi. The angular acceleration is a equals to v squared over r, that is velocity squared over r, radius. Then substituting the value of v, which is radius, times phi into this equation, we have that r phi squared all over r gave us r squared phi squared over r. Therefore, angular acceleration A is equals to r phi squared, where A is the angular acceleration. Centripetal force. Centripetal force is the force F required to keep the body of mass m moving in a circle of radius r and it r towards the center. Centripetal force is given by F equals to ma, which is equals to mv squared over r, where a is the acceleration of the body. Thus, centripetal acceleration A is equals to v squared over r. Centripetal force towards the center is now equals to mass m times radius r times angular acceleration phi, which is now giving us mr phi squared. Centripetal force F is equals to ma. F is equals to mv squared over r, or F is equals to mass times radius times phi squared. So looking at this body, it's being swinged by a string, and you see that the tensions and the force are acting towards the center of the point where the body is being swinged, and there will be a magnetic force pulling it and a tension pulling it up, and the force pulling it towards the center of the circulation. At position 1, the tension in the spring provides the centripetal force. T1 minus ma is equals to 0. T1 minus ma is equals to the centripetal force. T1 minus ma is equals to mv squared over r. T1 it now becomes equal to mv squared over r plus ma. At position 2, the tension in the spring provides the centripetal force. T2 is equal to the centripetal force. Therefore, the T2 is equal to mv squared over r. At position 3, T3 is equal to mg is equal to centripetal force. T3 plus mg is equal to mv squared over r. T3 is equal to mv squared over r minus mg. Example 2. If object of mass 50 kg moved at 5 meters per second round a circular path of radius 10 mm, calculate the centripetal acceleration, the centripetal force required to keep it in orbit. Solution. A. Centripetal acceleration is equal to v squared over r is equals to 5 squared over 10, which will give us 2.5 meters per second. B. Centripetal force is equals to mv squared over r is equals to 50 times 5 squared over 10, which will give us 125 Newton. Example 3. A mass of 0.5 kg is wide in a vertical circle of radius 2 meters at a steady rate of 2 radio revolutions per second. Calculate the centripetal force. Solution. Angular velocity phi is equal to 2 pi f, with f representing the frequency. then substituting the value of the frequency